So I will present the Extrasolar Planets Encyclopedia, how the world's encyclopedia says it helps you to know everything about exoplanets. But I will start with a question. What is, after all, an exoplanet? Why do I ask this question? Because one of the main components of the encyclopedia is a catalog, and we want to know what to include, what objects to include or not in the catalog. And after that, I will present the structure of the encyclopedia and the future developments. So, to define an exoplanet, there are two problems. Conceptual definition, and once you agree with the definition, if you agree, there is another problem. Is the object you are observing fits to the definition? Now, there were two steps in the definition of an exoplanet. An historical definition, for instance, by Luhmann et al. In 2008, that there is no deuterium burning in the object. And this leads to an upper mass of 13 Jupiter mass. But yes, I must say that this definition is not endorsed by the IAU-F division. A more recent definition rests on the formation scenario. A planet, by definition, is formed by the accretion of dust and pebbles in the circumstellar disk. For this object, there is no reason that they cannot grow up to 13 Jupiter mass. Now, there is a second problem. Once you have the data for an object, do this data fit the definition, which is the formation scenario? But we don't have the video of the planet formation. There are other objects which are called brown dwarfs, which are formed by collapse of a gas cloud. But Chabrier et al. In 2010 have shown that brown dwarfs, after this definition, can have a mass lower than 13 Jupiter mass. So the mass is not a good criterion. In the exoplanet encyclopedia, we have followed a paper by Artie Access and Heike Rauer that by convention, a planet is an object with a mass lower than 60 Jupiter mass. But there is a problem. Measured mass can have uncertainties. So our final convention is that a planet is has a mass less than 60 Jupiter mass, plus or minus 1 sigma. Now I go to the structure of the encyclopedia. first of all, there is essentially a catalog with tools. I go a little bit smaller. A catalog with tools described in a paper in 2011. Presently, the catalog contains more than 5,000 confirmed planets and 3,000 candidates. But I rather switch to the presentation of the catalog itself. Do you see the screen of the website?
Yes, we can see it.
Okay. So we have a very extended bibliography with 25,000 references, a list of all facilities to search for planets, a list of all meetings, a list of some theory work and other sites. In the catalog, we have a tool which is the contrast ratio of the planet and the star as a function of time. That means along the orbit. So for a given planet, this is useful to observers who want to observe a planet by direct imaging, and so they know at what time the contrast ratio is maximum. We have a list of almost all other sides of exoplanets. In this list, you have, of course, EMAC. We have also the habitable planet, the habitable zone gallery by Avi Mendel, etc. And we have also a partner forum of which is a forum to exchange information on exoplanets, and presently we have more than 1,000 subscribers. So I come back to my PDF, and I will present future evolution. We will make a structuration of the bibliography sorted by molecules. We will have more data by molecules, atmospheric characterization, and more tools and more diagrams. And for instance, we will have a robotic importation of new exoplanets. For instance, when TESS suddenly presents 200 new planets, we will include these planets by a robot. We will have more correlation diagrams, and we will have EXOREM, which will be downloadable, and which predicts the lines observable in the atmosphere of a planet for a given instruments. This is based on a work by Benjamin Charney, and which is, of course, useful for JWST. We will provide spectral energy distribution for disk and fit them to predict the flux of a given disk. And finally, an online 3D modelization of exoplanet atmosphere. And I will stop here. Thank you very much.
Thank you very much, Jean. We have time for questions. I don't see question yet in the chat, but I have one question. You show the tool for the direct imaging prediction.
For what?
For direct imaging.
Yes.
I was wondering, you speak also about some line and SED for the disk. Do you have a tool to predict transit, for example, for planets?
It is under construction.
Oh, okay, that would be very good.
We will have a completely new website at the end of the year, of this year.
Okay, great. Is there any question? I don't see any. So if there is no question, we're gonna move to our next talk, and thanks, Jean, again.
Thank you very much. Bye-bye.